Hi, it's Mr. Baumgarten with a quick introduction to object-orientated programming. Now, the idea of this video is to just give you the big idea without getting into too much of the technical theory. I'm not going to be talking about terms such as inheritance or polymorphism or encapsulation if you've read about those on the internet. This is just the minimum bare essentials to get a functional project up and running. Object-orientated programming, the idea behind it is to bind the data and the functions that manipulate that data together under a single variable name. And so you can pass the two around very conveniently within your code. So what is an object? You have used objects already in your programming without realizing it. A string, apparently, just an object to you. All right, a string is just an object. And in this case, we are creating an object called s, and we are setting it to this particular this value. And we know that, yeah, I can print s and it's just going to print that out, that's fine. But there's also, if I hit the little dot next to my variable name, I've got a bunch of variables and functions that I can access that are related to string. And so I could say print s upper, or I could say s count the number of spaces that appear within the string. And if I run this code, it works. It prints out the uppercase version and it prints out the number of spaces. And if I created a second string, I can do the same thing and I get the different answer because S2 is a reference to this data, whereas S is a reference to this data. And I haven't had to change anything else in my code. The count function is attached to the string and it is able to internally tell which string it is linked to. We've also used objects when we've accessed files. We might create an f variable, and attached to that is a .read function or a .write function, and we use that to manipulate files. And the same also happens with dates and times. I can create a time object, and linked to that are things like the .year, .day, .month, or the .spf time, and all these other functions that are attached to it, and it automatically knows which date or time I'm referring to from the variable that I originally created. So that's what an object is. How do we go about using them or creating our own? And that's where we need to understand what the idea of a class is. A class is like the blueprint to a home, where the object are the individual homes that have been created from those blueprint drawings. So the class is the template code, I guess, if you like. So let's create a simple class called person. Actually, no brackets there, we don't need them. So create a class called person, and so within this class I indent straight away and I start including the functions that I want to be linked to any objects that I create based upon person. And there's a special function that all classes have, and its name is _init_, and its first parameter will always be self. If I print hello, all right, it's not going to be doing much, it's just going to say hello. All right, but that's a very simple class. And so if I create an instance of this class or an object based upon it, I can just say Groot is equal to a person, and that creates an object called Groot of type person. And when I run this, it will actually say hello to me. So what it is doing, it is looking for this init function. So init being short for initialization. So every time you create an object based upon this class of person, it will automatically look for and run the $init function to initialize it. And then self is an object that is a reference to itself that we use internally within the class. You must provide it as the first parameter to any functions you create in your class. And so I'll show you now how self works. So for instance, in person, let's give this some extra information. Let's say I am Groot in here. So I'm passing his, let's say it's his name. It's not his name, it's his saying, but anyway. All right, and so because I'm providing it as a parameter, I add it as a parameter to my initialization function. And I want to say self.name is equal to name. And what this will do when I'm come down into the actual object and I hit my dot, I now have a name property. Right? Because here I have said when I create my object of type person, and I run my initialization function, take whatever the parameter called name is, and create a variable linked to whoever I am, self, all right, create a dot name. So self gets automatically substituted within the template code for whichever object I happen to be. So in this case, it's equivalent to saying Groot.name is equal to name. Hence why I can now print out a Groot.name later on. But I want to use the keyword of self within the class so that if I have multiple objects, in this case, let's make up another one called Iron Man. And I'll print out Iron Man's name. That's going to print out correctly. All right, it's going to print out I am Groot and it's going to print out Tony Stark. And I haven't had to change the code in here, one for Groot and one for Iron Man. All right, whereas if I had put the word Groot in here, it would only be accessing this particular one. But by using the generic special keyword called self, it will automatically substitute based upon whichever object it is that I happen to be running it on. And so that's the important and the useful part of the keyword self. Let's add something else to this. Let's put in a date of birth. Now, I have no idea when these guys were born, so I'm just going to quickly make it up. Let's put Groot in for Star Wars Day. So May the 4th be with you. He can be in the year 2020, and Tony Stark can be born on Pi Day. So the 14th of March, let's make him 1990. All right, so this is going to be, this is another string being provided as a second parameter. So I need to save it to myself so that I can then reference it later on. All right, so I can just do, and these names don't have to match. I could call this birth date if I wanted to. And I would now have down here, print Groot, hit the dot, and I should have, if I scroll, yep, a birth date. Fantastic. Now I can create secondary functions based upon all this. I might want to make another function called getAge. All right, and I don't need to provide any date of birth or anything else as a parameter because I am an object that has access to all these properties. I can just look up my existing date of birth. So I can use self.birthdate within my own functions and will automatically substitute for whichever object it is that I'm running the function on. So let's get today's date, datetime.now, and then calculate an age. So this would just be self dot, well, actually I need to convert the birth date. At the moment the birth date has been saved as a string. So let's convert that to, let's just say, I'll call it B for birth date. Date time dot strp time, and I get the self dot birth date. So look up that string and convert it. %d, %m, %y, and so now my age will just be today dot year minus b dot year. Return the age. All right, and now I can print Groot.getAge and print ironman.getAge. And it will automatically substitute in the correct dates for each for Ironman and Groot. And I forgot to do my import statement, so let's just quickly do that. From date time import date time. Run this. Okay, so what have we got going on here? Groot's age is 0 and Ironman's age is 30. Groot's age is 0 because he's born in 2020. And so let's just make that the year 2000. Okay, and it says he's 20. All right, now obviously this is not a full complete age function because it's not taking account of, have I passed his birthday yet, and to increment or decrement the age. But the overall idea of how it works in terms of creating a function that's attached to the class that we can reference the individual properties, that is, and you can see that working there. So this has been a lightning quick introduction to object-oriented programming. Hopefully that helps and you can use it as necessary within your projects. This is Mr. Baumgarten signing out.